Today we face cyber attacks around the world once every 39 seconds. But despite this, we still rely heavily on usernames and passwords, a 60-year-old legacy security.
This is particularly true for OT devices, such as PLCs, where username and passwords are typically the only level of authentication.
Some of these devices still in use today don't even have a username and rely simply on just one system password that is freely shared amongst users.
The problem? How do you keep secure access to legitimate users only? Now the problem becomes even more acute when you consider PLCs are becoming increasingly connected to other systems.
Usernames and passwords are no longer viable on their own. Static information is easily stolen, copied, shared, or hacked via brute force or dictionary attack.
So the IT sector for several years has been bolting on additional levels of security, 2FA and MFA, to mitigate the inherent weaknesses. The problem for the OT sector is the current 2FA and MFA solutions require a constant, reliable network access for token exchange or public key infrastructure.
This type of solution is not easily deployed in OT environments. Latency, slower user experience, more points of failure, and potential lockout due to signal or network issues are all likely to be unacceptable in OT environments.
Here at swIDch, we think our one-time authentication code technology solves this problem. OTAC uses a locally generated dynamic code that achieves single-step login and MFA combined. This steps up your authentication to MFA standards while keeping the user interface quick and easy.
The dynamic OTAC is generated locally by the user on their smartphone or their chip-enabled biometric identity card without needing any network and achieves secure identification and authentication in a single step.
Once generated, the OTAC is valid for only a few seconds and is for single use only, which means it's highly secure and cannot be copied for reuse later.
Finally, you can forget usernames and passwords forever. This also means vastly reduced overheads for OT security teams.
So the solution can be deployed in several modes.
Firstly, directly on the PLC itself. This is ideal for PLC operators managing small numbers of devices and users. The solution is completely offline and standalone and even works for fully air-gapped devices. Secondly, on a central server within the local network. Ideal for bigger PLC operators managing larger numbers of devices and users. Finally, hybrid, where OTAC is deployed both on the central server and the PLC itself, allowing users to authenticate through a central server, but also, if the network is down, users can still authenticate locally.
So how does this all work? The solution is based on a shared secret between a client, the device responsible for generating OTAC, like your smartphone, and a server, the device responsible for verifying OTAC, like a PLC. Our solution is based on and approves upon TOTP, time-based one-time passwords. This is the same technology that's used by Google and Microsoft Authenticator. On the client side, we first generate a TOTP using the shared secret and the system time. Then our proprietary algorithm injects and mixes the user identifier into the TOTP, which results in an OTAC. The OTAC is then transferred over to the server, typically by typing in the code, or automatically by a QR code, NFC, or Bluetooth. On the server side, we do the reverse. We extract the user identifier and the TOTP from the received OTAC. The server then generates its own TOTP based on the user secret and the system time and compares this with the TOTP received from the OTAC. System automatically adjusts for small differences in the system clock times and allows for small entry delays by the user. If everything matches, the result, along with the user identifier, is passed on back to the PLC. All of this happens in a few milliseconds with very low compute overhead.
Super secure, super simple. Next generation security for PLCs with swIDch.